All right, welcome back. We are Game 2014, Mobile Game Development 1 in the fall 2021 semester at George Brown, and it's week 4, part 2 of our broadcast. And let me just do one thing here. I want to make sure that we've got a link that I can put up on Blackboard because that would not be good. Let's go back on Blackboard and do that under course documents. So course documents week 4, you'll see that there's a link for adaptive for mobile part 1, and let's make another link, and it'll be the same name, but it'll be part 2. All right, so what did I do? Edit. I'll be okay. Let's submit. There we go. So again, if you need to watch remotely on YouTube because that's a better thing for you, then there it is. So you can see that now. All right. Meanwhile, let's go back to what we were doing. Where we left off, we were on the Mac. All right. So I used Chrome Remote Desktop to access my Mac, which is right here, and I was able to over the break finish my build. I built it across, and I got these kind of build warnings and so on, but it was all good. And I built it for my phone. So now let's switch back to the PC. To do that, I don't need this anymore. The simulator, I can close that off. Let's go back to my PC and see what I've got. So again, we were running with Unity, Lab 2B, and I'm using a little app called Reflector, right? So for those people who have a Mac and they want to use their Mac as a target for their, you're using an iPhone and you want to use your PC as a target for your projector, there's something called Reflector 3. So, and of course now it's been moved to Reflector 4. That's the new one. And what Reflector is, it's made by these guys, Air Squirrels, and they used to be called Air Squirrels. Now they're called Squirrels. And anyways, what this allows you to do is I can use my PC or Mac as a target for my iPhone. And so that's what the thing I've done. It's not free. It's $24 Canadian, it looks like, which is not bad if you're doing mobile development all the time. If you're not, and you're doing what we're doing here, don't spend your money. This is just a way of projecting your iPhone onto your PC, which is what I've got happening right here. And so what the Reflector app looks like is it gives you kind of one of these, which allows you to kind of connect your iPhone, to the device. And I'm going to do that right now with my iPhone. Just 1 second while I just finish what I'm doing. All right, let's see how this works. So again, what I'm going to do with my phone, just like normal, is I want to use I want to do screen mirroring and target my desktop with Reflector 3. All right, so this is what I've got, the old version, Reflector 3. I didn't upgrade. And so what I'm doing is
someone is at the front door.
Of course they are. And I'm targeting this right here, and it gives me a bit of a code, and I'm able to put my code in and then start streaming on my on the machine, right? So that's what this thing does. And so now you can see that I've got my phone. This is what it looks like. Let's make the phone a little smaller, right? As an example, because it's my phone. And what I've done is I've gone ahead and downloaded my Game 2014 F2021 app, and this is what it looks like, right? So kind of cool. I know it's pretty crazy. So you can see that it's not terribly bad, all right, when it comes to the phone itself. I think when I put it on my iPhone, we're getting approximately the same thing that we got before. Let's go back to Unity, locally on my machine here, on my PC, and let's pull up Unity and see what it looks like, right? So So again, I want to compare what my iPhone is doing compared to what I'm normally getting with my device, right, with my Unity stuff. So let's take a look at that. So again, you can see that this is my actual phone and what's going on with Unity today. There it is. And let's take a look at my scene for my start scene. That's not bad, right? The actual phone itself relative to what my build is on my device, and it's almost identical, right? Now, the good thing is I can actually do stuff. I can play the game in Unity. And one thing that also or on my device, I can also turn it to a landscape mode. And you can see that automatically when I turn to landscape on my device, it looks pretty good. Like it's not bad, okay, in terms of how it works. So if I go next, you can see that I have a landscape, kind of right. If I go restart, it goes back. And I can keep going back, and I can go also rotate it back to what it says here. So relatively, guys, I think it's pretty good in terms of the functionality that we wanted, which is really good. So that's all I wanted to do today with the iPhone, just to prove to you that for the most part, if you put this onto your actual phone, it looks pretty good, right? It looks pretty good. Okay, so that's what it looks like right now. Any questions around this before we move on? And guys, I just need 1 second. I'll be right back. I got it. Looks like I got it. Is it okay? Okay. My wife needed me for a delivery, but now it's okay. All right. So that's kind of how it works. So it's pretty good in terms of the way it is. And again, if you're using something like Reflector, that's okay. If you're using another tool, you can also use what I had before, which is Visor. So there's another tool that I recommend for you. Visor's free. So it looks like this. This is Visor. One day when it comes up. So Visor, what it allows you to do is actually stream your emulator or any actual device on your machine as well. So that's I really find this is a really good app as well, Visor with a Y. And you can download this if you want to check it. If you ever want to do presentations or if you want to do a video, as an example, it's really good as well. So let's go to that. And let's put in Visor as another download. So I think this is a pretty good download again for those who want to try it out. I think this is a pretty good one. And it's free to download, and you can stream your phone on your machine. So if you're doing videos for me for your assignment part 2, and you want to show how the functionality of your phone and an actual device a little bit better than what we're seeing here, especially when you're using touch controls, then you really want to target something like with an actual device, like with Visor. So Visor is pretty cool because it does both Android and iOS, right, as an example. But Visor has some limitations in terms of what it can do for free. So again, notice that it asked me when I brought up Visor, hey, I don't have you have to have test flight going, on your machine and blah, 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 and then you can make it work. And so I find that when I have two kind of applications. One of them is Reflector, and I use Reflector for my iPhone, and then I use Visor for Android devices. And I think those two things in combination work really great for what you can do. All right, so that's something that you may want to do later on. Any questions around the stuff that we've talked about so far today? All right, great. So that's the first part. So Visor's free. Yeah, you can download Visor for free. You can use it for free. It's great for your Android phone, and it's great for recording. Like if you want to record your video, you can use OBS, bring it up, and then you can record yourself playing on Visor. And then as an example, it'll be better than the emulators. Instead of doing something with something like LD Player. LD Player is a great emulator for testing, but when it comes to actual, there's nothing the same as doing it with your actual device. That's what I'm trying to get at, right? So if you're going to do it with your actual device, that's great, that's fantastic. But the problem with it is you need to have, for your actual device, you need to have some kind of way of projecting, a projector. And those two that I mentioned are probably the good ones that I would recommend: Reflector or Visor, which is free. So again, for those people who are interested, Reflector 4 is what's out there right now. And again, if you're going to be, if you're someone who is going to be an app developer, I find that you need, especially for presentations and that kind of stuff, you want to show off your app to your, or your game to prospective, investors, or if you just want to show your game on a big screen when you're in a game jam or something like that, and it's from your phone, then you want some kind of screen mirroring or screen projecting software. And the two that I found that are good are Visor and Reflector 4. Here, or Reflector is what it's called. So I'll put the links here for you guys. There's Reflector, and this is Visor. So that's going to be in your chat windows there. Yeah, those are the two that I recommend. All right, let's wrap this up. All right, so let's go to this. So now that we've kind of done this, but how do I do it so that how do I make sense of all this stuff when it comes to the safe area? How do I deal with it, right? Because the safe area is something we've been dealing with on an automatic basis, but maybe there's a way of getting something done on a kind of with scripting. How do I do that? So let's go take a look at the Unity stuff. So if I go to Unity and then I look at something like the safe area, okay, if I can actually spell safe area properly, yay. And if I look at the Unity code, you can see that, or the kind of version. By the way, we're using Unity 2021.1. So I recommend always to shift to the latest version of the API relative to what you're looking at. Sometimes you look things up and it gives you whatever the version was that you found on the web, but this is what we want to see. So notice that we have the screen itself gives us some information about the safe area, right? So if I look at screen, which is an object, right? And again, this is in the Unity Engine Core module, so it's available all the time, right? Take a look what it says. Auto rotate to landscape left. It enables this by code. Auto rotate to portrait. It also allows you to do things like brightness. You can get the current brightness and so on. There's some DPI, full screen, height, right, as an example, which is the current height of the screen in pixels. Orientation specifies what the orientation is, so you can start detecting things. Safe area, which is interesting, and width, right? So there's also some static methods, which can kind of do the, can switch the resolution. Let's take a look at safe area. And again, it says returns the safe area of the screen in pixels. Okay, so this is interesting. So it gives us information about the safe area. And remember, what it returns is a rect. And the rect gives us width and height. That's an object that we get from Unity, right? And what it has, a couple things. What it can produce for us is the extents of an object, where we get xmin, xmax, ymin, and ymax to give us the rectangle of your safe area. Now that's really interesting, because now if we want to, what if I want to change the anchor, right, as an example? So if I type in the word anchor right here in my scripting API, let's see what it does for us, because we want the anchor to a canvas, right? So that's what we want, the canvas anchor. If I go back, let's just search it. It's easier this way. So canvas anchor, as an example, Unity. Is there something that's going to come up there? Basic layout, it says 101 for Unity. Maybe there's another. The rect transform is what we really want, the rect transform anchor, right? So let's search for that instead. Rect transform anchor, right? And is there something we can do? Here's rect transform 101, right? So is there something we can do to programmatically change the anchors? Well, here's min and max, right? For my rect transform. So does it allow me to do that, right? Because what I want to do is I want to change this so that I can adjust for my screen. So we can get information. Let's go back one little bit. We can get information about my safe area, where my safe area itself is a rect, and the rect gives me X min and X max. Those things are really, really good, right? So what about if I wanted to change the rect transform and change it to something else? Let's see what I can do in Unity. If there's something we can do here. And this way we can adjust the screen, where my object sits, based on the safe area. Especially not necessarily for this, which is kind of in the middle, but where if I go to main in here. Okay, so I want a relative, kind of mark from the safe area. And right now, if we look at our back button as an example, we can see that the rect transform gives us a local position X of 465, right? So what if we were to do something like that? So right now we only have one script, which is the UI behavior script, right? Let's add another script, and we'll create almost like a game controller script that allows us to kind of control the game. Let's add that in. So again, I want to right click and add a new empty object. That's how I would do this. In my empty object, I'm going to call this empty object game controller. And inside my empty object, I want to have a new script, right? And so for that, I need a script. Let's make one. So right click, go to create, and go to C# script. And let's call this game controller, same name. So my game controller script and my game controller object right here. I want to drag and drop my game controller script on top of my object where the button is the easiest place, like so. And then it adds my game controller script to my game controller object. Okay.
Be called a game manager.
Doesn't matter what you call it. If you're comfortable with the game manager, go ahead. But I use game controller.
It's like game manager in the example.
That's okay. Again, it doesn't matter what you call it. Some people call it world manager. Some people call it lots of stuff. I've seen it in many ways. All right, so game controller's here, and let's double click on game controller right here to launch it. Notice that game controller or game manager or whatever you want to call it, doesn't really matter. It has a couple of the default functions, start and update. It's really up to you how you want to, whether you want to use these or not. What we need is a reference to the button. And, we need to know that it is a canvas UI button or a rect transform at the very minimum. If all I need to know is the rect transform, right, or as an example, that's okay. But one thing is that we need access to the screen itself. So notice that there's nothing really here that gives us a specific access to the screen, but we can put something over here. So let's say, for example, I want public. Public means we'll see it in the inspector like before, right? And if I say that I want the screen, it's going to be a type screen. Okay, so I want to get the screen itself, screen object. And let's suppose I call it screen, little s for screen. There it is. So this is the screen itself. And I want to get access to this thing. I want to get access to the screen. Now, it's a screen. It's not the screen. Okay, that's one thing to note. If I want to see the screen, then it's screen. So I'm kind of hiding it. But what I mean is, if I say screen, and if I say that's equal to screen, capital S, right? It doesn't work, right? See, it says like, I want to make a new screen, what the screen is. So for me to get a screen size, so if I say something like by itself, if I use the static variable screen dot, and I want to look at safe area, where safe area is a rect, right? As an example, I want to be able to share the information of the rect up here. Let's make this a rect. Okay, here's a rect instead, and this will be the screen rect. And what I want is this safe area to be kind of be transferred, this rect to be kind of on the screen. So I can say that the screen is equal to this, right, at start. And hopefully what we'll get is the transform of the screen. If we want it dynamically, we would move this from here and put it here. So that was like the screen itself would be always readjusting what it looks like every frame. Now let's see what we get when we do that. Do we get anything? And does a rect even compute when it comes to the inspector? Sometimes there's going to be certain kinds of objects, as an example, that you try and make public in the inspector, and they just don't work. Okay, let's see what happens. So if I run it, and if I run the code here, and I'm inside of the back button, you can see that it's running right now. I can see that the width is 1440, and hey man, what happened? I thought the height was supposed to be 3040. What's going on? How come this is a problem? Because I'm getting the safe area, right? So the actual safe area of the screen is what I'm getting. The safe area is here, but if I go to the screen itself, right? So this is the safe area. Let's revamp. Again, I'm just going through it. Let's go. Let's call this the safe area, right? And then we'll also do a public rect. Just bear with me. A public rect for the screen itself. All right, so the screen and the safe area. And let's see if we can get both of those values, which is what I want. So again, safe area is going to be safe area. And then screen, I want to equal to the screen itself, but I want the screen rect, right? The actual dimensions, the width and the height, right? Is there a rect that I can put for the screen itself? Notice that there is not, but we do have a resolution, right? But a resolutions is resolutions array, right? So we have those things. We have cutouts. That's interesting that we have that as well as a rect, right? And cutouts is a rect array, but that's really all we have. And we have the safe area, which was also, if I start typing safe area is also a rect. So what can we use that's similar to this to create something? Well, we could make it so that we can make a new rect. So we can say, like, you know, let's just make it so that rect, we'll call it a screen rect, right, is equal to a new rect. And we can put in a, x, y, width, and height, which is what we want. We'll make the x and y 0. So 0.0, 0.0, and then the width and the height will be screen dot width and screen dot height for now. This creates a rect, and then I can say that screen is equal to the screen rect. Got it. Woo. And if I run it, let's see what we get. We're going to get a screen rect and a safe area. Let's see what they look like if I did it right. If I did it right. Hey, that's what I'm looking at. Does that make sense? So we can instantly see, Vincent says, it's also possible to have a constructor for screen passing and just screen width and screen height. I think so. But what I'm showing you here is the height is the thing that's different, right? One thing that one problem that we have, and I got to talk about this, is the safe area itself. It says that our x and y coordinates are 0, 0. What is the safe area relative to the screen, right? Because the cutout is at the top, right? And if we want to do it like just by eye, if we want to say that this is the relative size of this is the 0, x, and y coordinates of the safe area, right? But it's relative to the safe area itself. That's why these values, x and y, make no sense, right? So what else do we do? So 0, 0, it says, Vincent says 0, 0 will go to the 0, 0. What's the last code? Sure. It's just this. All I've done, Yanov, is just all I'm doing is this, right? So I've got a couple of rects, and then all I want to do is I want to set the screen rect, as an example. I made my own rect, and I made my screen rect, and I added in the width and the height of the screen, and I set the position to 0, 0. So we can calculate this, right? When we can say the difference, if I want to find the difference in heights, because that's where it is right now, the difference in heights is where the problem is, right? If we suggest that the screen size itself is the height, we know that the top is where the cutout is in most screens, right? We can also get the orientation. So screen dot orientation, right? And it's going to return some kind of object. Now it says screen orientation. It specifies the orientation, right? That's what it says. But what type is this thing? Screen orientation itself. So screen and then orientation is the type, right? So what is this type? Screen orientation. It's an enumeration. That's what it is, right? Where we have portrait upside down, landscape left, landscape right, and auto rotation, right? So these are the things for the enumeration, okay, that we're seeing here. So if screen orientation is a orientation, or is a enumeration, and they're just integers, then I should be able to output what that is. So if I go back to my game controller, and if I say something like debug.log screen orientation, then we should get a continuous screen orientation every frame. So stop this and relaunch it. And let's see what happens. So it says screen orientation portrait. Okay, what about if I change in my simulator? Can I do that? And will it make an orientation change? You know, as an example, would it show landscape, right? And the answer is no. Okay, so it doesn't detect the orientation change, you know, as an example, right? There's no orientation change that occurred right here. So it just says portrait. Okay, what if I stop it and start it again? Now it says landscape left. Okay, and if I want to change the orientation, it says portrait. And if I do it again, it says landscape right. And you can see that it detects the orientation changes just right. Notice though that it didn't do the upside down mode because we don't support upside down, right? There we go. Let's try it again. Let's go to the left, right? This landscape right. And we also have portrait. Okay, so we know we can detect all those things. Yes, it should work with Visor. It should work with everything, because really with Visor is just a projector. And the emulator that we're talking about, thanks Max, is what we're doing. So screen orientation, because it's an enumeration, we can do a switch case on this thing, right? And if we do a switch case, then we can tell where the safe area is, right? If the safe area is at the top, for example, let's do a switch. And this is something for you guys to take away. If I go to screen.orientation, and what I can switch for, I can do different cases. So case, and if I notice it says landscape left or landscape right, I can do that. So case landscape left, let's do that. We can also do a case for screen orientation landscape right, right? So different things. And we can also do a case for screen orientation portrait. We don't care about portrait upside down mode because we're not going to make a change to that when it comes to this, right? And we can also have a default case. So default, right? Which would give us some kind of other result. So we could frame it this way, no? And it says, so you probably do an update method while we're at it. Go ahead, do an update method if you like, right? I'm going to do this way. And what I want to do is when we have landscape left, so let's run it again. It's going to ignore the switch case because it doesn't do anything right now. So when I do landscape left as an example, so instead of portrait, if I do, you know, kind of rotate it to the right, landscape right, there's my landscape right, when I'm in landscape right means that my safe area is shifted to the left, right? And landscape left means my safe area is shifted to the right, okay? Also, notice the changes up here, right? Where my safe area actually shows an x-axis, right? For landscape right, my safe area actually switches to 142 pixels, right? Again, if I rotate it again, if I rotate it to the middle, you can see that there is no number, right? Which is actually incorrect. This is kind of a funny way of doing things. And let's do it again. But if I shift to the right again, right, you saw that from landscape right, we see nothing, right? We see nothing for landscape right. But landscape left, we see that the number becomes 142 pixels. Okay. So think about this, right? So think about what I'm doing. If I know that the difference is 142 pixels, I mean, we can pretty much calculate this right here, right? Because if I take, again, my orientation that I currently have minus my my safe area's height, then I have 142 pixels. But that's not always going to be the case with every single phone, right? Some phones are going to have a different orientation and a different resolution than what I have right now, right? And let's check that out. Let's move from a Galaxy S10 Plus to something else, like an iPhone, right? So if I go to an iPhone XR, which is what I was using, right? Make it a little bigger so it's the same size. And bring this in and bring this across, just so make it so it's the same. So it's obvious what was going to happen here. Remember the 3040 and the other number that we have. If I was to run it again, right, with an iPhone instead, now we get different numbers. And on top of that, we have a y-axis change as well, where the safe area on the y-axis is down about 68 pixels. Okay, that's what it means. And so we have 1792 on the width is the same. So this is cool. But if I was to change the resolution, so it says landscape right, you can see we get some changes where the y-axis is still 42 pixels. All right, that's interesting. 42 pixels on the right, on the y-axis as a change, right? And the safe area on the x-axis is 88 pixels. Look at that. Right, it's again interesting the way that the safe area makes sense. So for iPhones, Samuel says, why does it have a safe area along the bottom in landscape? For iPhones, you have a swipe bar that appears at the bottom of the iPhone when you touch it, and when you swipe up, it'll actually kind of remove the phone. Same thing goes with the bottom. If I go this way. The reason why there's this little area right here for an iPhone is there's a swipe bar that you can't see right here that allows the user to touch it and swipe the object up. Like the home button, exactly. Okay, so that's what it allows you to do. But this is peculiar, isn't it? Take a look. I've got 68 pixels on the y-axis. Is it this, the difference between the cutout and this part right here? Is that where the y-axis is? Because remember, 68 pixels is a difference between the height that we're getting and the height of the safe area. Okay, let's try a different phone. Let's try something like, if we can go back to an iPhone, let's go to an iPhone 12 Pro Max, right? So here's the iPhone 12 Pro Max, right? And let's move off of this and rerun it, okay? And now let's see what we get for a safe area. So again, the screen resolution is 2778, and we can see that the safe area is 102 pixels down, right, with a smaller height and the same width, right? So 102 pixels down, but this area looks the same, but this area right here looks bigger. So just keeping this in mind of what it looks like. So the safe area actually has a buffer. This 102 pixels is this. away from the cutout, guys. Here's the cutout, and this is what we're talking about here, right? And it doesn't include the bottom. The bottom doesn't have a, kind of a thing. It starts 102 pixels down from the cutout. That's what it means, right? And we have this other area right here, which equates to 2,535 pixels, right? The whole height of the object, okay? So this gives us hints on what we can do. If I rotate it to the right, again, now we can see that where does the safe area start on the x-axis? 141 pixels. 141 pixels, okay? And the y-axis is still 63 pixels. But there's nothing that shows in the top, but there is something that shows in the bottom. So these things are quite confusing in terms of the way it works, right? The safe area x and y coordinates are relative. What would be nice if we had the x and y coordinates based on world space, right? Then it'd make it a lot easier, right? But I'm pointing this out to you because if you want to design some kind of responsive layout, we can get orientation changes, and we know that on the right side is where when I go landscape right, then I know that as an example, the cutout is to the right. Okay, in this case. Let's go back one more time, and then I'll move into something else, another topic. Let's go back to our Samsung Galaxy S10 Plus, which is what we're using. And again, notice that there's no margin on the right and the left, nor on the bottom. No margin on the bottom, okay, whatsoever. And we don't even have a margin on the top. Why? Because look at the cutout. The cutout, which is really the camera, is hugging the safe area. It's hugging the safe area, right? So if I was to run it again on our S10 Plus, right? Again, just to notice things, we have a difference, but everything is zeroed out. Why? Because the cutout on the top left corner, there is no margin. There's nothing. There's no buffer. But if I turn it, right, there's no buffer on this side. But what if I go the other way, right? It shows that we have a safe area on the left of 142 pixels. So that's interesting. Okay. So what can we do? Any ideas on what can we do based on the information we've been given? Or is there any other tools we can use to make this different? Because we want to be able to be responsive. We know we can get the rect transform for the buttons, right? I can do the rect transform for the buttons. How do I move a button, as an example, to a specific spot? Right? What if I want to move a button up, programmatically? How do I do that? Right? Let's actually try and move a button. And again, to do that, okay, we can offset the button. I like it. I like your thoughts. These are good thoughts. But how do we do it? Let's go back to code and see what we can do from a button. So this is kind of something that we can get. As an example, I haven't saved everything, but I'm going to save it now. So this is kind of an example of how we can adjust code based on orientation changes. And we're doing this switch case here in the update. I can make it like we said before, I can kind of make it so that this piece here, and I know that Yanev had mentioned it before as well, we can make it so that we want to extract. So if I go refactor extract, I can extract a method, and I can extract this method based on the name that I want. And so let's say, for example, I want to call this on orientation change, or check orientation. Let's say that was the name that I want, right? And then if I click next, then you're going to have a check orientation method that's going to be something that's simple over here, right? So we can kind of program this and we can keep our update method nice and clean compared to, kind of configuring that in here. Getting the rect information here, that's something else that we might be able to use somewhere else. But what about the button? Let's see if I want to get the rect transform of the button. So I want to get the rect transform, and I want to get, we'll call this the back button. Okay. Okay, so let's call it a big, kind of big long name like that. We'll make it public. And then that back button rect transform, what I want to do is the back button rect transform, can I set it? Can I say that, notice when I do this, I get anchor max and anchor min, offset max, offset min, and I get the pivot. And I also have a rect that I can get out of it as well, right? So that's something I can also do. And the rect gives me some information, again, about X and Y coordinates, right? So is there a way of changing, you know, this stuff altogether, right? How do I do that? And what do I do? I've got some getters here and I've got some setters, but they have nothing to do with the button. This is just generic game object stuff or from mono behavior. So what can I do, right? I can get anchor min and anchor max, but I want to get information about the rect transform itself. So we can respond with a rect. The rect itself, again, if you look at it, it's a rect that we want to do it. So we don't need the whole rect transform. I want to just get information about the button. Let's see what I can do first. So if I say this is a rect, right? So back button rect is what I want. And the back button rect is what I want to output, right? So I want to take that back button rect and I want to drag and drop it in there. I don't need to do anything here as an example, but the rect is the most important piece. Let's do that out here. So inside of my game controller now, I'm going to have an extra slot, and my back button rect is going to be right here, but it's looking for some kind of, it doesn't allow me to drag and drop the back button rect. It just gives me some basic information. So how do I do that? Well, I want to find the back button. So I can say something like back button rect is equal to, and I want to find object, and I want to talk about find object. I want to find the object in my hierarchy, right? I can find objects of type, or I can do a find object with tag, or find object, you know, I want to find objects with some kind of tag that I want to tag it, right? I don't have a tag for the button right now because the button, my back button is untagged. Let's make a new tag for the button, and we'll just call this back button, just so I can identify it. So here's my back button. No, it's not. So back button is if I, again, I'm just using a tag for my button. So let's go back button. Nice, 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 right? And I want to find the back button just for this case, just for testing. So again, what I want to do is I want to say find. And again, I can go game object with tag, the game objects with tag, this one, and I want to put back button. And when I get that game object, it's a game object, but I want to get the back button rect, right? So I want to say that as, I want to cast it as a button type, right? That's what I want. And once I cast it as a button, I need to include Unity UI, right? And what I want is for me to get the rect from the button itself. So the rect transform, or the transform itself, is what I want. But notice that even when I cast it as a button, right? I wasn't able to get out the rect transform when I did this. Game object, find object with tag, blah, 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 right? I can find the back button, and I'll get a reference to the back button itself. It'll be a UI button. But when I do this, when I say as button, when I use the as keyword here in C#, it tries to cast it as, or put it in a box as a button, right?
Or you can do as.
That's something else I can do too. But
Just keep typing it on my IDE. It like shows that up.
Nope.
It's because the capitals there. Capital B.
Oh, back button rect. No.
The capital B on the second button.
What are you talking about?
Lowercase b and then capital B right after. Is it the two lowercase b's?
I'm sorry, I'm not getting you, man. I don't understand. It's a namespace issue.
Just look at how you're writing button rects. It might be a namespace.
No, it's not. You can't do it this way. This is the rect itself can't be a back button rect. Like, that's not the case. This is the game object, the static game object, the thing that I'm using, this find game object with tag. The back button itself is what I've put in here, back button, right? That's what it's looking for. So I've tagged back button to this thing, so I can find the back button. The challenge is trying to cast a game object as a button, right? Because generic game object does not have a rect transform. It only has a transform. Any game object just has a transform. Back button rect itself will just give you this. That's not what you need, right? It won't work for you. So if I cast it as something, right, you can see that I can cast it as a button, or it says in Unity UI elements. If I cast this as a button itself, using button is equal to this, right? And then maybe I want a rect transform is what I want. But notice I only have a transform and I don't have the rect transform. But we know that even if we cast it as a button, let me go back to what I had before. We know that the transform is just a fancy word for rect transform. Dot. And I want to get the information from this as a rect. That's what I want. I want to get that information back as my back button rect. That's what I want. Okay? Because button, if I was going to go that, let's just say button is equal to a new button, right? And I say that, let's suppose that button also needs a couple things. My button, right, dot rect also is an issue, right? Notice that I can't get a rect from the button, right? But here, if I go public button, where it's the button itself, and let's just call this my button just to make a difference. If I did this up here, right? And if I go my button dot, and I can get the transform of the button, it's still a button, but there is no rect transform. I can get the tag of the button, I can get a bunch of other stuff in the button, but the rect transform itself, not available. So how do I get it? How do I get the rect transform? Because my transform and my rect transform are two different things, right? This is what I was trying to show you. So transform, the rect transform itself, gives me relative positions to my canvas, right? And the canvas, because it's a screen space, it's an overlay on top of the screen space, on top of the camera, right? It's something it's not in world space, it's in screen space, right? But it's going to give us a relative position of the canvas. The canvas is kind of like 1-to-1. It's 0, 0. The 0, 0 mark of the canvas is the top left corner of the screen. That's what it is, right? So the canvas fills up the entire screen space because it's matched onto the main camera. But the rect transform of the button is relative to its anchor and to the canvas itself. All right, so trying to get the rect transform here directly like this is not possible.
Someone is at the front door.
Another person's at the front door. Anyways, so to end this talk, because we were talking about how to do it and everything else, we're going to say that, again, I could cast certain things, get rid of all this. But the idea is what we want to do is, I need 1 minute. Okay, thanks. What we want to do here is we want to be able to capture the actual location of the button if we want to move it. Because if I get a button and I call it, for example, something like back button here instead, right? And when I go to my game controller here, if I go to my game controller, then let's suppose I just drag and drop the button in here, so I get a reference to the back button itself. right? And if I want to output debug.log, and I want to output the back button, for example, transform.position, there's two. There's local position and position. This is the position in world space, and local position is the position relative to the parent transform, which is our canvas. All right, so let's see if I can get local position, and does that make any sense? And then we'll end for this particular session. So when I do that, I get relative to the canvas, right? I'm getting my back button as -255 and -1240, right, from the canvas, and then 0, 0. So X, Y, and Z. So how does that equate with the back button? So take a look at that. -255, the back button, right? And -1240. It's right here. That's this back button local position. If I do a back button position with the thing, there's also other ones we can use. If I just do position and I run it, we get a 0.8, -4.1, and 90, which doesn't make any sense either, right? So that doesn't make any sense either. What about, can we get something else, right? For example, the back button, instead of the transform, can we get the anchor or something like that? And even with, or the pivot, can we get access to that? Because it is a button. It's not just a game object. And so that's something that we have to, kind of look at as something that we're going to explore in the next session. Okay. But again, the discussion here today was all around, can we get information for the button? And notice that for the rect transform itself, the way I'm doing it, these numbers and the back button doesn't make any sense. They don't compute, right? When it comes to the transform, the local position, and the regular position, okay? But hints for you for next time when we get together is, what can we do here? Can you think about a piece of code that we can put here to adjust our button position or our layout based on landscape left, landscape right, or portrait? When we get back again next week, we'll talk more about this. Okay, that's it for me today, guys. For you guys, just a reminder before I go, for the people that are here, remember that your first part of your assignment 1 is due on the weekend, on Sunday. For your lab, the only thing I need for you guys to do is make it so that the buttons work. So I can actually go from one screen to the other. We kind of had it mostly. And that they can work like this on multiple screens. You've adjusted it so that at least it can work in both portrait and in landscape layout automatically. It doesn't have to work better than what we have in terms of the way it is. So if I was to go and play, and then if I was to change my orientation, the buttons hang inside of your safe area. If you've got those two things working, you're golden for your lab 2, which is due on Friday. Okay, and that's it for me, guys. I'm going to stop recording this, and then I'll be right back. It's got a visitor.